Hi, everyone. My name's Sean, and today with my group members, Anran, Elizabeth, and Taylor, we will be talking about ethics in software engineering. So given who we're presenting to, this is maybe unnecessary to say, but it really is hard to overemphasize just how important and impactful software systems are to the modern world. I mean, they're so deeply ingrained of all aspects of our society, from a macro level like national defense, government, banking, telecommunication systems, but then even on an interpersonal level, they entertain us, we use them to plan our lives, and they even shape our ability and methods of expressing ourselves as human beings and our love to those we care about. And by extension, those who shape these systems, software engineers, have the ability to shape the world and make really large scale impacts. And a lot has been dissected and discussed about how to effectively make those impacts or efficiently make those impacts. I mean, this class is sort of an example of that. But it's also this power to make an impact that demands software engineers take pause and examine how exactly they're making impacts with the decisions they are, and whether those impacts in that software may intentionally or otherwise negatively affect people's lives. And so to ensure that these considerations are taken into account, ethics has to be a central part in the software engineering process. Before we can talk about how to apply it to software engineering and the process of it, we have to define the scope of what we're discussing. This isn't a hard stat, but I think it's fair to say that the vast majority of all businesses on Earth today use software in one way or another to implement their business. But whether or not those businesses are at large ethical does not fall into the domain of software engineering ethics. That's not to say software engineers shouldn't consider these things. Some ethicists will say that this is actually a big ethical duty of a software engineer. If they see something unethical going around the business that they're part of or that they're the provider for, it's their job to bring this to someone's attention, whether that's higher ups within the company or be a whistleblower to the public. But specifically, we'll be borrowing a definition of software engineering ethics from a framework that was created by a joint task force of two organizations, those organizations being the Association for Computing Machinery and the Institute for Electrical and Electronics Engineers Computer Science Group. Those are mouthfuls. They go by ACM and IEEE-CS, and that's what we'll call them the rest of the way throughout. And their definition from a framework that we will discuss in a moment defines software engineering ethics as ethics pertaining to the analysis, specification, design, development, certification, maintenance, and testing of software systems. So the framework that this comes from is known as the ACM IEEE-CS Code of Ethics. There are quite a few frameworks that exist within the field of software engineering that are somewhat similar to this, but we'll be taking a look at this one specifically as a means of showcasing a major framework and analyzing how to implement it into the software engineering process, and also the trouble and difficulties that you might face when trying to do so. So for context as to where this comes from, the ACM and IEEE-CS are two massive computing organizations, both with aims of advancing the field of computer science. And together they have a little under 200,000 global members. And also, it's important to mention that even though this was a groundbreaking initiative by the two groups, it was not the beginning of the discussion around ethics in computing at large. That finds its roots back in World War II with a man named Nicholas Wiener. But in the 1990s and slightly before that, there was an ethicist named Donald Gotterbarn who really helped shift the focus towards the ethics pertaining to the profession of software engineering. And those who pursue it. So in an effort to formalize guidelines for this growing profession, at first to educate and inspire, but also with the hopes of creating enforceable industry standards, Gotterbarn, the ACM, IEEE-CS, and two other ethicists published this joint code in 1997. It has been updated a few times. The most recent edition came out in 2008, and that's version 5.2, but it remains largely consistent throughout. As for the content of the code is centered around 8 guiding principles, seen here from version 5.2 in 2008. The principles are meant to represent the different relationships a software engineer must consider when working on a project. To go through them very quickly, an engineer must consider public interest in mind. They must ensure they're serving their client and employer as best they can within the confines of that public interest. They must ensure integrity of the product itself. They must ensure they are acting with their best judgment. Managers and those in charge must be leading ethically and promoting ethical behavior amongst their teams. Engineers should remember that they are responsible for the integrity of the profession at large in the public eye. They must treat their colleagues ethically, and they must hold themselves accountable. Each of these principles is further broken down into subclauses, anywhere between 8 to 15 in number. And each of these subclauses is meant to represent one of three levels. The highest and most basic of these levels is level 3, demand, which is essentially the bare minimum that all software engineers must remember. An example of this might be clause 2.02 in the client and employers principle, which dictates that an engineer never use illegally or unethically obtained software, so don't actively break the law. Level 2 is expect. It's less specific than level 3 in its directives, but the clauses of this level are meant to express the considerations that a software engineer owes to the people who might be affected by their work. For example, clause 1.07 in the public principle expect software engineers to consider differences in physical ability or economic barriers that may hinder a public's use of the software. Lastly, we have level 1, aspire, which is meant to establish ideals towards which engineers should strive. Clause 6.02 in the profession principle is a pretty good example of this, which encourages engineers to promote public awareness and knowledge of software engineering. Collectively, these principles, clauses, and levels are meant to provide a structured framework for engineers to follow as they develop, design, test, and maintain software. But for how and where exactly it is applied into the process, I will turn that over to my group member, Taylor.
All right, so I'll go through a few methods that use this code of ethics. The first one being the reclassification method, which is very simple. It's when you basically give your team of engineers the code of ethics, and then you ask them to reclassify each subclause into a specific phase in the life cycle. So an example of that would be clause 1.04, which is about disclosing possible dangers of your software to the public and the user. And so this could be placed into the requirements phase, when you're determining the functionality of your software, or the maintenance phase when you might be introducing some new functionality. So you can see that a clause can be used in multiple phases, but the idea is to just narrow the focus of the developers so that they don't need to look at the entire code for each phase, but the ones that they determine they need to. And then there's another one is the ethical driven software development method, which is similar in that it subdivides up the code into the different phases of the life cycle, but it goes a step further and transitions them into questions to be asked and is like a checklist to be used by the team. So an example would be during like the requirements phase, if your customer asks you to do something that contradicts the values of your company or is maybe even illegal, do you have a method to deal with that? And so you just want to make sure that at each level you can answer yes to every question. And then there is the ethical deliberation for agile processes method, which is slightly different than the other two. Instead of so then you look at the entire system that you're going to be building and who is impacted by it and what the goals are, and then you select from the code of ethics the values that you think apply to this project. So instead of going through every single one, then you narrow the scope at the very beginning of the project itself. Then you'd go through the goals and see which of the values actually conflict. So you can see that all methods are designed to just bring the ethical code and these questions related to them to the forefront during most phases of the development process. Okay, and then so the manager's role in all of this is similar to what we learned for lean development. It's to make these ethical values clear so that every developer understands where the company stands and where their team stands on and can make their own decisions as they relate to lower level choices in the development process. And then you also want to create an environment where developers are comfortable speaking up, and so that you can get contribution from everyone on your team, since the more contribution, hopefully the less bias that you have in your ethical values. And then, of course, you want to have a procedure for identifying and reporting the unethical behavior, and also incentivizing ethical development with maybe a prize for some nominated team member. And then why should a company build ethically? Well, I mean, the first answer is pretty obvious. It's generally seen as a good thing to be ethical. But besides that, there is evidence to suggest that building more ethically leads to better employee engagement, since people are happier when they're working for a company that they can be proud of. And then this increased employee engagement then in turn leads to better productivity from them and then a better product. And then there's also a study that suggests that this will increase customer loyalty, since around half of customers will stop buying from a specific company if they find that this said company is unethical. So if you are building ethically, then there's smaller chance that you'll be losing customers this way. And so this will then lead to profits over the long run. So I'll just pass over to Elizabeth to discuss the shortcomings of using this code of ethics for development.
Alrighty, so while frameworks within the industry, including this joint ACM IEEE CS Code of Ethics, are clearly essential and have certainly played some part in promoting ethical behaviors, the current frameworks as they stand still leave much to be desired, particularly in the practical applicability of the codes or lack thereof, and in the content of the codes themselves. So firstly, the code doesn't include any concrete examples, even for ethical dilemmas that engineers may more frequently encounter. So as the code includes broad and at times vague ethical principles without direction or approaches for implementation, there's no clear way for engineers to apply these principles. And in this way, the code kind of fails to set out what it achieves to. So additionally, there are no clear consequences for violating the code. So while there are outlets from the two governing boards of ACM and IEEE CS to report violations, they don't really offer any further detail about how these violations are handled or any past cases in which something has actually come out of this report. So while members of the ACM or IEEE are sometimes legally beholden to these codes, membership to either of these boards is not necessary to officially adopt this code or to be a software engineer in general. So if we compare this, say, to the medical field, it's well documented that violators of medical ethical codes face possible debarring or disciplinary hearings, or in extreme cases, losing their medical license. For software engineers, however, the consequences are primarily at the discretion of employers, and it's mostly self-regulated. So one could argue that there is low incentive for individuals to adopt the code, and thus the code further lacks practical applicability. And so lastly, in terms of practical applicability, while the joint code that we've been focusing on is among the most notable codes in the industry, there's no official industry-wide ethical code currently. So while codes do generally agree on universally recognized ethical values, it is the variance within ethical nuances which is most common and probably the most harmful in the industry. So with multiple codes to pick and choose ethical principles from, engineers can cherry pick values as is convenient for them, and thus this kind of negates the purpose of the codes in the first place. So the content of the code is another of its shortcomings. So first and foremost, the code uses broad and vague language like public good and best interest, which can be bent and interpreted in favor of the interested parties. Since the code makes no effort in establishing a hierarchy of values, if there are differing or even contradicting interpretations, there's no way to settle these differences. One recent example of this was a legal battle between Apple and the FBI. So the FBI was requesting Apple to unlock the San Bernardino shooter's iPhone, clearly acting in the public good, while Apple was repeatedly denying this request, saying that it was in the best interest of their customers to not allow a potential backdoor security breach. So this standoff eventually ended after the FBI outsourced this task to an Australian hacking firm, Azimuth, I think it's called. So in looking at this code of ethics, both Apple and Azimuth would simultaneously be acting in accordance with the code, but also in violation of the code. With such strong contradictions within just one code, this is a serious ethical issue as it comes to accountability and consistency, and just another way that the code falls short. So furthermore, that any ethical code in this industry should be updated frequently as new technologies are constantly evolving. For reference, that this code that we've been referring to hasn't been updated since 2008, which means it lacks clauses that address newer technologies such as artificial intelligence or machine learning. So at this point, bias in artificial intelligence is well documented. As recently as 2021, Stanford researchers found that when prompting OpenAI's text completion system, GPT-3, with sentences including Muslim, the system completed the sentences with disproportionately violent and discriminatory ways, even when they tried to steer it away from these associations. So the fact that commercially available software can spread such discriminatory rhetoric is not only highly unethical, but could also worsen racial and economic inequities in this country. So clearly there's a lack of oversight in the development of ethical AI software, and the fact that the code has not been updated to address any of these is clearly not good. So lastly, the code does not acknowledge how to handle unintended unethical side effects. So what I mean by this is I'll give some examples. So say when Facebook implemented the like button, there was no way to predict that it could lead to social media addiction or impact the self-worth of young teens and adults. Or say when Instagram creators developed Instagram, at the time of development, it was probably likely that they were acting in accordance with the codes. But as we know, years down the line now, that Instagram has harmfully impacted the mental health and body image of young girls. So these unintended, unethical side effects are clearly becoming more frequent, and the lack of acknowledgement in the code is another huge shortcoming. So while clearly well-meaning, the current frameworks still leave a lot to be desired. So I'll leave it to Anran, who will dive into some case studies.
All right, for our first case study, let's take a look at Facebook as an example of unethical practice. So on the right is one of the internal research documents the whistleblower brought to light last year. It reported that hate speech and misinformation on Facebook are greatly affecting users and their societies, but Facebook is only managing as little as less than 1% of the violence-related content. On the left is another document provided to Congress. It's research on the relationship between surges in harmful Facebook activities and the riots in Minneapolis in 2020. It raised the concerns that Facebook was playing a part in inciting violent behaviors, and that's not doing enough to limit the damage. Similarly, there has been controversies around Instagram for creating mental health pitfalls for teenagers. On the right, we can see that in a survey, 32% of teenage girls reported that Instagram made them feel worse about their body image. On the left, there's anxiety and other mental health issues among teenage boys as well. These internal research findings were exposed by a whistleblower, not disclosed to the public by the organization itself voluntarily. So Facebook's behavior has violated a number of principles in the Code of Ethics, such as the principle of public, which prohibits the delivery of software that creates harmful environment or works against the public interest, requires disclosure of potential danger to users or to the public, and does not allow deceptive public statements. And similarly, in the principle of profession, the code asks individuals to express concerns and about violations of the code and report to authorities if needed. So these are ethical things that an organization should do if their softwares are harmful to the public, but Facebook didn't do any of them. For our second case study, let's take a look at IBM as an example of good ethical practice. The wording of the Code of Ethics is generic, which makes it hard to apply directly to organizations with their unique situations. IBM is an organization that has established their own code of conduct in developing ethical products. So the journey started 2016, where they published research on ethics. And in 2018, they formed the AI Ethics Board and defined their own approach towards AI ethics. They have established 5 pillars that organizations should consider when developing their AI products. Fairness. An AI model should be fair towards everyone, especially historically underrepresented people. Explainability. The company should be able to explain to the public how the model is created, what data is used to train the model, etc. Robustness. The model needs to be making trustworthy decisions. Transparency. Facts about the model should be disclosed to the public. and data privacy. Users and customers' privacy and rights should be protected by the model. And IBM has also released open source toolkits that will help developers to follow the guidelines of these 5 pillars. This would also encourage other tech companies to start their journey towards their own ethical development. IBM's also committed to educate their own employees as well as the public. Their employees would receive mandatory trainings on the company's standards on ethics. And they also have partnership with various research and educational programs that aim to educate the general public about how AI works. So overall, this is what we would like to see organizations do. Take the code of ethics, create guidelines that are suitable for their own situation, and have management actively implement these standards throughout the organization. And I will pass it back to Sean for a conclusion.
Thank you very much. So based on everything we've read and all the sources we've compiled, going forward, well, Anran just said it is great when companies are taking the initiative themselves to really have a lasting impact. In line with Donald Gotterbarn's original vision, we think that there should be an industry-wide standard established in these various areas and ethical review boards set up to ensure that engineers are and companies at large are following those ethical standards. And maybe more importantly, ethical considerations really have to be the foundation of any software project or organization, not just an afterthought years later when studies and whistleblowers have revealed how much damage has been done. It should be an active, habitual, and ongoing process, starting with hiring of, a variety of voices and backgrounds to make sure that they're equally represented in the industry and in each individual project, and then every stage thereafter in project management. Every individual involved in development, from the managers to the junior engineers, should be asking questions like, what impact might this decision have, and how might this be misused? Software's influence on the world is just going to continue to grow, and the impact that it has on tomorrow's world is up to us, software engineers, and ultimately the ethics that guide us. So thank you for watching this. Thank you for my team members, and have a nice day or night.